Introduction to statistics. Statistics involves the collection, organization, presentation and summarization and interpretation of data. Descriptive statistics is a branch of statistics that involves collection, organization and presentation of data. Inferential statistics is a branch of statistics that interpret and draw conclusions from the given data. Basics of statistics. So we need to know what is population. Population is the entire group of people or things that we want to study. Now, sample is a smaller group taken from the population, which is the group we actually collect data from. For example, if we consider an investigation into the weights of adult women, then the population would be a complete set of weights of every adult woman in the world. The sample is the smaller collection of weight measurements that has been observed or collected from a subset of this population. So population would be everything that we want to study, and then we take some subset of people and let's call it the sample. A sample is considered biased if it does not accurately represent the population concerning the characteristic being measured from the given data. Now, we can have qualitative data. Qualitative data describes qualities or characteristics that cannot be measured numerically. It focuses on label, names, categories. Think of it as data you observe or describe. So qualitative data would be everything that is not number. For example, color could be blue, red, yellow, and so on. Gender could be male, female, and so on. Nationality could be American, and so on. So those ones are example of qualitative data. Quantitative data or numerical data consist of numbers that represent counts or measurements. It is data that is always expressed numerically, and it can be analyzed using mathematical operation like addition or averaging. Think of it as data you can count or measure. Now, in qualitative data, we can have discrete data or we can have continuous data. Discrete data would be data that is measured by whole numbers. For example, number of students, number of cars, because we cannot have half of a student or 1/3 of a car. Continuous data would be data that can have halves or 0.5, would be like height, temperature. We can take any value within the range. So for example, age, it can be 25 years old, but it can also be 5.5. So this would be called continuous data. Height or weight, it can have also halves. It also is continuous data. Now, number of pets, we can have 0, 1, 2, whole numbers. So that's called discrete data. Discrete data only has whole numbers, whole positive numbers actually. Temperature would be another example of continuous data. Types of statistical studies. We can have observational study, where researchers observe or measure characteristics of the sample members, but do not attempt to influence or modify those characteristics. Then in this observational study, we can have retrospective study. That means observational study that uses data from the past, such as official records or past interviews, in which the sample naturally divides into cases and control. Case, those who engage in the behavior, controls those who did not engage in this behavior that's been studied. Now we have another types of statistical study that would be experimental study. Researchers apply a treatment to some or all of the sample members, then observe the effects of the treatment. And in experimental study, we have couple terms. We can have treatment group, so that would be group of sample members who receive certain treatment. They get some medicine or other treatment. Control group would be group of members who do not receive the treatment. Now, placebo would be lack the active ingredients of the treatment, but looks or feel enough like the treatment, so the participant cannot distinguish whether they are receiving the placebo or the treatment. We can also have placebo effect, a situation where patients improve simply because they believe they are receiving a useful treatment. Now, experimental study can be single blind or double blind. Single blind means participants do not know if they are members of the treatment group or control group. So participants do not know if they are receiving the treatment or not. And double blind means participants and experimenters do not know who belongs to the treatment group or control group. Now, methods of samplings. First method of sampling that we would like to discuss is simple random sampling. Every person or item in the whole group or the population has an equal chance of being picked for your sample. It's like drawing names completely at a random. The goal is to create a sample that is very likely to be representative of the overall population without any bias towards one characteristic. For example, if you have a list of all 100 students in one grade in a high school, to get a sample and you want to study some characteristic of those students, to get a sample of 10 students, for example, you can assign each student a number from 1 to 100 and use a random number generator to pick 10 unique numbers. Then the students corresponding to those numbers are in your sample. So we have a population and we want to choose a sample. We can assign a number to each member in population and randomly choose some numbers that correspond to the people and make the sample. Another method of sampling would be systematic sampling. If you select a starting point at random and then choose every nth person or every 10th person, every 5th person from the list or sequence. The goal is to get a sample that is evenly spread across the entire population, often easier and faster than simple random sampling. So if you have a list, for example, if you have a list of 500 customers and you want a sample of 50 to survey if they like your product, calculate the interval, for example, 500 divided by 50, you have 10, then you can select every 10th customer. So systematic sampling, we systematically select every other person, every 10, every 5th, whatever works. Another method of sampling is called stratified sampling. Stratified sampling is when we divide the entire population into important non-overlapping subgroups. Those groups are called strata, based on shared characteristics, for example, by age, gender, or income, or by grade. Then you randomly select from each subgroup a sample. The goal is to guarantee that the specific subgroups are correctly represented in your sample, especially if those subgroups are important for your research. For example, a company wants to survey 200 employees about a new policy. They know that their workforce is 60% male, 40% female. Then divide the employee list into groups male and female, and then choose accordingly. So they can choose 60% from the male and 40% from the female. Or they can choose equally, even if the sample is more male than female. Depends on what is needed for the study. Another example of sampling would be convenience sampling. You choose people or items for your sample simply because they are the easiest and most accessible for you to reach. It is driven by ease and not randomness. So this method is very high in bias because the sample may or may not represent the whole population. The goal is to get quick and inexpensive data collection, often used for pilot studies or when generalizability is not the primary concern. For example, a student conducting a quick survey on campus about study habits stands outside the main library and asks the first 50 people who walk by to participate in his study. These people are so-called convenient to the researcher, but may or may not reflect all students' population because some students may not visit the library. That's called convenience sampling. Now we have example. An auditor is tasked with verifying the value of a company's physical inventory, which consists of 900 items stored in a warehouse. The auditor decides to choose every 15th item to a total of 60 items from the for a detailed check. Identify the sampling method that was used in this study. So to identify, we would choose one of those ones. So is this a random sampling, systematic sampling, stratified sampling, or convenience sampling? Random sampling, we choose randomly. Systematic sampling, we choose every other, every 10th, every 15. Stratified, we divide into groups, male, female, or by grade. Convenience sampling would be easy people who respond to survey or people who first walk to the shop or anything like this. So since the auditor is choosing every 15th item, we can see that the sampling is systematic sampling. So the answer would be B, systematic sampling, because it's every 15th item. Another example, a student researcher is conducting a preliminary study on the number of hours universities spend on homework per week. Due to time constraints, the researcher asked 15 other friends who live in the same dorm. Identify the method that was used in this study. So the researcher is choosing 15 of his friends. So that's not random, that's not systematic, that's not stratified, that's very convenient for him. So the type of sampling is called convenience sampling. Now, to organize data, we need to be able to present them. So the data can be presented using frequency table, pie chart, bar graph, or a histogram, or a line graph, or other ways to present data. We will learn about all four here. So frequency table is a way to organize data by listing all the possible values or category and showing how often each one occurs. The frequency is the count of how many times a particular item or value appears in the data set. For example, suppose a teacher records the favorite color of 20 students and the colors are red, blue, yellow, and so on. Create a frequency table. So we would list all possible color that show up in the survey. Now we would use the tally to calculate how many of them. So for example, red, we have red, we had red right here, we have red right here, we have red here, here, and more reds and more reds. And then if we calculate, we have 1, 2, 3, 4, 5, 6, 7, 8. So we record the frequency as 8. The same we would do with blue, calculate how many times blue shows up and count that 6 of them show up and so on. So for the total of 20 students. Now, a relative frequency would be the percentage. 8 represent what percentage of all students. So we simply take 8, divide by 20, and red shows up 40%. Blue is 6 out of 20 and shows up 30% of the time. Green is 4 out of 20, so it's 20%. And of course, all of them needs to add up to 100%. Another ways to represent graph is to using the pie chart or a circle graph. A pie chart is a circular graph divided into slices or sector to show the proportion or percentage of each category relative to the whole. The entire circle represents 100% of the total frequency. So we have example like essay grade on the data. We can see that 36% or roughly 1/3 of the pie is receive C, and then 28%, which is very close to 30, almost 1/3, receive B, and so on. So this is called the pie chart. Now we have a bar graph or a bar chart, uses rectangular bars of different length to compare the size of the different categories. The length or height of the bar is proportional to the value they represent, which are often the frequencies from the frequency table. So for example, here we have frequency of essay grades. So here are the grades, here is frequency. So letter A or grade A, 4 students receive. So we draw the bar for 4 students. Grade B, we have it that 7 students receive, so B shows up 7 times. Grade C was received by 9 students, and so on. Grade D was received by 3 students, and so on. Now, histogram is similar to bar graph, but is specifically used for continuous data that has been grouped into intervals or bins. So, for example, here we have a tree, and here is height. So we have height of the tree. So if the height is between 100 and 150, that's the number of trees show up. So probably around less than half. So three trees has height between 100 and 150 centimeters. We can see that then there are 30 trees that has height between 150 and 20. So the histogram shows the range of data, where the bar graph shows the exact values of the particular data. And we can also represent data using the line graph. It's a visual tool that uses points connected by a line segment to show the trend in data. So here we have example, we have a number or flowers sold during weekdays. So here we have a number of flowers, and we have Monday, Tuesday, Wednesday up to Friday. So on Monday there were 10 flowers were sold. On Tuesday, the company or the store sold 30 flowers. On Wednesday, the same 30 flowers were sold, and so on. So we have the points of data, and then we connect them with a straight line. Let's call it the line graph. Now we have example. The data below shows the size of classes at a given school. Represents the data using frequency table, using bar graph, line graph, and pie chart. So let's go with the frequency table first. So we're gonna create the table first. So we need to have the data. Here we would put tally, and here we would write frequency. And here we can write relative frequency. All right, so let's keep writing. So here is our data. Here we would count. So, and here would be my frequency. And here would be my percentage relative frequency. So what we have what is our smallest data that we can find? 26, 27, 28. So we have 26, we have 27, we have 28, then we can have 29, then we have 30, and 31. Then we had 32 as well? Probably not. So then I would keep going. So I had 30. I can put one mark by 30. This would be my tally that I'm counting. And then, so the 30 is already done. Then I have 28. So I put one tick by 28, 27. Then we have 31. Then we have 26. Then we have 28, 27, 28 again, 30, 31, 30 again, 28, 29, 30, 31, 29, 30, 31, 29, and 30 again. And then we can count. So 26 shows up 1, so we have 1. Here we have 2, here we have 4, so we keep filling it 2, 4, 3. Then we count, we have 1, 2, 3, 4, 5, 6. And then we have 4 right here. So then here would be total. And total we should have 20. So we have 4 and 6 is 10. Then we have 3 and 3 is 6, so 10. So indeed we have total 20. Now we can calculate the relative frequency, so represent each in as a fraction, as a percentage. So we have 1 out of 20. If we divide 1 out of 20, it's 0.05 or 5%. Then we have 2 out of 20. It would be 0.1, which is 10%. And fill it up, all of them. 4 out of 20. 4 out of 20 is 0.2, and that is 20%. Then we have 3 out of 20. It's roughly 15%. And then we have 6 out of 20, and that's 30%. And 4 out of 20, so that's 20%. And then it should add up to 100%. If we keep adding them, all of them together, we should get 100%. So this is my part A. This is the frequency table. That's how we create the frequency table, that we show the frequency. Part B represent data using the bar graph. So part B, we would draw the graph, bar graph. So on the bottom, we have given data. So we have 26, then we're gonna have 27, 28, 29, 30, 31, and that's it. So now we have 1, 2, up to 6. 1, 2, 3, 4, 5, 6, and that's it. So 26, we draw a bar that is only 1. and the bar around the 26. Then 27, we draw a bar that is size of 2. So on the size of 2, that's my graph, and that's my graph. We can later fill them in. 28 shows up 4, so 1, 2, 3, 4, 5, and 6, right? So 28 shows up 4, so we need to have a bar on the 4. And 29 show up 3, so we need to have a bar on 3. 30 shows up 6, so we need to have a bar up to 6. And 31 is 4, so 31 is 4. So this is my bar graph. We can fill them in with the color if we want, or just keep it as is, it's okay too. So this is called the bar graph. Represents the bars for each given data. Now for part C, represents the data using the line. So we're gonna draw the line, part C. So the same, we can mark it as we have it right here. 1, 2, 3, 4, 5, 6. So 2, 4, 6. And here would be 26, 27, 28, 29, 30, and 31. So 26 is at 1, 27 is at 2. So this is the frequency, right? Here the same, we would have frequency. And the same was here, frequency. 28 we have 4. 29 we had 3. 30 we have 6. And 31 we have 4. So we would connect them with the straight line. And that's called the line graph. Now the last one, they asked me to represent the data using the pie chart. So then we're gonna go with the percentages, whatever percentages we're getting. So we're gonna draw part C, part D. We're gonna draw the big circle. And now out of that circle, let me draw a nicer circle. Now we're gonna divide the circle into portion. Typically we start with the largest one. So the largest one is 30%, so roughly 1/3. So we would divide this whole circle into kind of third parts, a little bit less because 100 divided by 3 would be 33%. So I think it needs to be a little bit less than that. So just a little bit less than 30%. So 1/3 roughly, it's gonna be my highest one. So this is my 30%, and that 30% represents to the class size 30. So we're gonna write size 30, so that later we can read the data. So this is my first slice, 1/3. Now we're looking for the second largest, which is either this 31, 20%, or 20, class size 28, 20%. So now we know that 30 and 20 is 50%. If the whole circle represents 100, 50% would be exactly half of that circle. So we're gonna extend one part, and this is my 20%. And I can mark either that the size is 31 or 28 because they both have 20%. So let's mark the 30 class size. 31 is right here. So this is 20% of this one. Now exactly the same what we have 20%, we need to have another 20% for the second one, which is the size, class size of 28. So now I'm gonna mark exactly the same, roughly the same stuff. So it's 20%, size 28, 20% size 28. So far we mark it, we've done this, and this. So then we keep going, we take the second, usually you start from the largest. Then we have another 3 to represent. So the 15% is the largest out of those 3. So we need to choose another 50%. So roughly that's gonna be my 50%. And that represents 15% represents the size of 29. So we're gonna mark it size 29. And then we have 10 and 5. So this would be my 10%. 10% is size 27. And then 5% would be size 26. So this is roughly my pie chart. We can use different colors to represent 30%. 20% would be different color. This one was also 20%. And then we have 15% right here, and so on. If we make bigger size the circle, then the data would be a little bit nicer represented. Example 9. The following data represents the scores out of 50 that 15 students receive on a recent math quiz. Represents the data using the frequency table, bar graph, line graph, and pie chart. So exactly the same as we did shortly ago, right? So we're gonna do the frequency. So part A, we're gonna do the frequency table. So we need to have all the data represented. So here would be my data. Here we can keep counting. Here would be my frequency. And then we're gonna do percentages as we keep going. So we have, let's look what is the lowest number or score students receive. I see the lowest is 30. So we're starting with 30. Then what is the next? What is the next number? 30, 35. We don't have 32. So we mark 35. Then we mark 40, 45, and 50. And here we're gonna count. So we would go 45 and we put one mark. 40, 35, 45 again, 50, 40, 30, 45, 40, 50, 35, 40, 45, 30, and 40. And then we count. So here is my frequency. So we count that we have 2. Here is 2. Here you count 1, 2, 3, 4, 5. Here we have 4 and 2. So total we should get 15. And if we add them 2, 4, 9, 13, 15. So indeed we have total of 15. And the next one we find the percentages. So we divide 2 divided by the total number by 15. And that 2 divided by 15 gives me 13%. Then we have another 2 by 15 gives me 13%. And 5 out of 15 gives me 33%. Then we have 4 out of 15 gives me 27%, and then we have another 2 out of 15, that's 13%. Total should add up to 100% as we keep rounding. So part B, we need to draw the bar graph, part B. So the data, here is my data. The data, we need to mark it. The data, we need to mark it always on the bottom. Here is my data. So we had 30, 35, 40, 45, and 50. And here would be my frequency. We have 2, 4, 6, 2, 4, 6. So 30 shows up as 2, so that's my bar. 35 show up as 2, that's my bar. 40 shows up 5 times, so that's my bar. 45 shows up 4, so 4 is right here, that's my bar. And 50 shows up again 2, that's my bar. So this is the bar graph, and we can color them to show nice bars as we keep having those ones. So this is called the bar graph that represents the numbers. So we have 2, 4, and 6 on that side. Part C, use the data, represent the data using the line graph. Part C. So we had the same frequency, we had the same data. 30, 35, 40, 45, and 50. Here we have 2, 4, and 6. 2, 4, and 6, and between is 1 and this one. So 30 shows up twice, 35 shows up twice, 40 is 5, so mark the 5, 45 is 4, so we mark it at 4, and 50 is 2. And we connect using the line, and that's called the line graph. And part D, use the pie chart. So we draw the bigger circle, and now we're gonna divide the circle. We look always for the highest go first. So 33 is almost exactly 1/3 of the pie. So we divide the pie into thirds, and that's, we take 1/3, that's my 1 part. So this gonna be my 1/3 pie, and we mark it 33%, and we mark it that this is score 40. So this is my 33, and the score is 40 right here. So this is the first one. Now, second largest is the 27, which is very close to 30. So 27, we would mark it. Oh, we can use different color. We would, if this one, if this whole part is 33, then, or 30, 27 would be a little bit less, right? So we're gonna mark it 27. It's very similar to 30, but 27%, and the score for 27% is 45. So this part we can erase it. Okay, so now we're looking for the next. So we completed 27 and the score of 45. And then we have all three equally divided, 13, 13, 13. So this remaining part we can equally divide into 3 and put each of them equally down there would be 13%, right? So if we roughly equally divide them, then we getting, and then we can mark 13%, and this is score 30. Then we can mark another 13%, and this is score 35, and then another 13%, and this would be score of 50. And this is my whole pie chart. So we use the score 30, 13%, 13% score of 45, 13% score of 50.